Hello, and I'm glad that you're all here. My name is Mr. Jenkin. I teach math here at Notre Dame Academy. And we're going to do something fun today. We're going to do press buttons and eat M&Ms. But we're going to do that in a math kind of a way. I like to press buttons and eat M&Ms. We're going to do that in a math kind of a way. And so you all have 3 packs of M&Ms in your possession. You got them when you were coming in. And what I want you to do is count how many M&Ms are in each pack. So you can't combine them all together. You have to count them each separately. So we gave you 2 bowls. One in case you want to empty them out into the bowl and count them. Put them into the other bowl. The other bowl will hold all 3 of them. But I need to know how many M&Ms are in each pack. Be sure you don't mix the packs together before you've counted. Okay, now once you've done that, we're going to make a list of all the numbers that you gave us. And so what I've written down here is the list of how many M&Ms in each pack. Well, I kind of like to know whether the number of M&Ms that I got in my pack is, more than average or less than average. As you can see, they're not all the same. So what I'm going to do is I'm going to put together what we call a distribution of the number of M&Ms in each pack. So you can see down here at the bottom, I have looks like a number line. And I'm going to make my x-axis, that's my x-axis, and I'm going to call this number of M and M's in a pack. Actually, it's in a fun pack. It's not a regular bag, it's a fun pack. And I'm just going to put these numbers on here, and it's a dot plot. So I can see that I started with 4 that had 18 in them. And just so you know, that these are in order is just kind of the way I did it so that I could get a nice distribution. It'll obviously be different every class period. So I'm going to put a dot here at 18, and 1 above it, 2, 3. So I have 4 dots at 18, and then I have 3 dots at 17. 1, 2, 3. 2 dots at 15, a dot at 14, and a dot at 12. And then I have 3 dots at 19, and 2 dots at 21, a dot at 22, and a dot at 24. This is what we call a distribution. And if you kind of sketch out the shape of it a little bit, maybe you've seen this kind of a shape before. Sometimes we call that a bell curve, because it looks kind of like a bell. Maybe you can kind of see why it looks like a bell if I look at this bell here. What it's saying is that it's kind of low on the end, and then it gets high, and it kind of evens out a little bit. And then on the other end, it starts to decline, and it gets low again. So that's why we call it a bell curve. Let's take a look right there again. Kind of a bellish shape. Sometimes in statistics, we call this a normal curve. But you're probably more familiar with the word bell curve. One of the things it shows us is that most of the bags of M&Ms are kind of around here in the center. Most of them were like right about average. And that's a whole lot easier to see it on that graph than it is by just looking at these columns of numbers right here. I mean, you might be able to tell with these columns of numbers, but it's much easier to see it on a graph. And if you can imagine, if we were trying to find the average of like 10,000 fun packs of M&Ms, I mean, these numbers there'd be so many of them, there'd be no way to tell it all. Putting it into a graph is going to give us like this really nice, clear, easy way to see about where the average is. Another thing that the graph shows us is how much variability there is between the different packs of M&Ms. I mean, I had some packs that had only 12, and I had other packs that had all the way to 24. Again, most of them are right here in the center, but that's a pretty large amount of variability. That's a pretty big difference between the smallest bag and the largest bag. And again, much easier to see here if we make a graph of it than it is if we just had to look at the numbers by themselves. Well, that's a nice thing to say, but you can imagine if I had those 10,000 packs of M&Ms and I had to make one of these dot plots right here, I mean, that would take me forever. So instead of doing one dot at a time by hand, I can use a calculator to do this type of work for me. So we're going to learn how to use a calculator to give us a distribution. So everybody has a calculator in front of you, and if you just turn it on with this button right down here in the lower left-hand corner, right there, the on button, you should have a blank screen. And the first thing we need to do is we need to take our individual bag sizes, bag amounts of M&Ms, and enter the data into the calculator. Now, we're going to do this by hand, but if we were really doing a large-scale scientific experiment on this, we would have ways of inputting that data directly into the calculator so that we didn't have to do it by hand. But right now we'll do it by hand so you can see what's going on. So the first thing I'd like you to do is push this button right here that says Stat, and then push the number 1. And that brings us up to a bunch of lists where we can enter our data. So we're going to enter the data. I had 18, enter, 18, enter, 18, enter, 18, enter. 17 3 times, 17, enter, 17, enter, 17, enter. 15 2 times, 14 once, 12 once, 19 3 times, 21 twice, 22, and then 24. So I have 18 data items, and they're all entered into that list. So what I'm going to have you do right now is I'm going to have you push the graph button right up here in the upper right-hand corner. And what's going to happen is you're going to get this really nice picture that looks very similar. See, with that bell shape, looks very, very similar to the dot plot that we made over here. And this is called a histogram. Again, you can see how much easier it is to do that if I was able to just zoom that data right into the calculator and just press that graph button. I would get this nice picture of my distribution. Now, it turns out that this bell curve kind of a shape is common not only with bags of M&Ms, but it's common in nature. For example, one of the things that we like to do here at NDA is every year we make a human histogram of our senior class. So this was our senior class of a couple of years ago, and you can kind of see. They're all got lined up by height order, and you can kind of see it has the same bell curve-ish type shape. It's not exact, but most of the kids are right in here in the average. And then we have some that are pretty small and a couple that are really pretty tall. So again, it really makes it easy to see, well, what's the average, how much variability is there. It's really nice to have it as a graph rather than just have everybody tell us their height. What if I wanted to find the exact average, the exact middle? Well, I mean, in our example here, I can tell pretty clearly that our exact middle is going to be 18. But if I had a lot more data items, or 10,000 of them, it would be a lot harder to do. And you're familiar with average, where you add each number up and then divide by the number of items. Well, my calculator can do that for me automatically. So what I'm going to have you do is I'm going to have you push this Stat button. And then over here, we're going to scroll over to where it says Calc. So we're going to make some statistical calculations. And we're going to make one variable statistical calculations. And the data that we used was in that first list that we entered in. So I'm going to go second, 1, and it's in my L1. And when I press enter, it gives me all these statistics. It tells me this X bar right here means that that is my mean. That is the average where I added up all the data items and then divided by the number of data items. But it also gives me another way of finding the middle, which is this thing here called the median, which is, in our particular case, is also 18. So our median and our mean are both the same. How do I know which one is better to use? Well, of course, in our case, the median and the mean are very close together. In some places, they'll even be identical. But let's just say that I had one bag of M&Ms, an additional bag of M&Ms that had way over here, this was a really stuffed up fun pack, and it had 50. So all my data is still centered right around here. I have this much variability in most of the data, but I have this one thing way, way over here, which we call an outlier. Well, what would that do to my averages? The first thing I'm going to do is I'm going to go back to my list. And I'm going to go to the bottom of my list. And I'm going to add in one more pack of M&Ms of size 50. Now I'm going to find my calculations again. Well, let's see what the graph looks like. No, I won't even see it on the graph. I'm going to redo my calculations. So stat, calc, one variable statistics. It's still all in L1, and I hit enter. Wow. Well, look at my mean. That 50 has now made my average go up to almost 20. It's over 19 now. But what happened to the median? Well, the median didn't change at all, because the median is the data item in the center of all the data here. This one over here, this outlier, doesn't really affect where the center of the data is. It just kind of, but it has a big effect on the mean. So you can see a few things from this demonstration. One is that graphs can make information or data much more easy to understand. Two, calculators can make calculating a lot easier. Three, different types of centers, averages, mean, median, they should be used under different circumstances. And four, M&Ms are good to eat. So go ahead and eat your M&Ms and enjoy the rest of your open house.